All right, let's get right into this explainer and break down what is, quite honestly, a masterclass in infrastructure planning. Today, we're looking at how India plans to build a multi-billion-dollar high-speed rail network, literally from the ground up. We're talking about transforming a legacy railway system into a futuristic, hyper-connected web. And the strategy behind it? It's absolutely fascinating.
Here's our quick agenda for today. 1. The high-speed dream. 2. The mega corridor case study. 3. The price of speed. And finally, 4. The master builders.
Let's kick things off with Section 1, the high-speed dream.
To set the stage here, just take a look at this rendering. It perfectly captures the sheer, staggering scale of what Indian Railways envisioned in their historic Vision 2020 white paper. You see, they recognized that while India has one of the largest rail networks on the planet, it was completely missing a high-speed corridor that could push past 250 kilometers per hour. So, to fix that, they envisioned these state-of-the-art elevated tracks slicing right through the landscape, which neatly sidesteps the massive headache of land acquisition in super densely populated areas.
And check out the geographic scope we're dealing with here. This map outlines the proposed Diamond Quadrilateral. The goal isn't just to build one really fast train. It's about connecting massive commercial, tourist, and pilgrimage hubs across the entire subcontinent using a network of elevated corridors. We're talking about linking up Delhi, Mumbai, Chennai, and Kolkata, basically creating a high-speed spine that fundamentally changes how a billion people move and do business.
Now, before we get completely lost in the heavy data, let's actually define what high speed means in this specific vision. It's a really smart two-pronged approach. First, they plan to upgrade their existing conventional passenger lines to hit speeds of 160 to 200 kilometers per hour. But second, and definitely more dramatically, they're building brand new dedicated tracks through public-private partnerships. And these new tracks, they're designed to push trains up to an incredible 350 kilometers per hour.
Which brings us to Section 2, the mega corridor case study. Now that we've got a handle on the national scope, let's zoom in and look at a really granular pre-feasibility study, the Pune-Mumbai Ahmedabad corridor.
So let's ask a pretty straightforward question. What does it actually take, engineering-wise, to bridge these massive economic hubs at those breakneck speeds? Well, a consortium of international experts, including Wrights, Sistra, and Italfer, actually ran the numbers, and the scale of what they proposed is pretty breathtaking.
The blueprints from that consortium study reveal some massive civil engineering requirements. Look, to maintain a speed of 350 kilometers per hour, your tracks have to be incredibly straight. That means 550 kilometers of earthwork, 72 kilometers of highly specialized bridges and viaducts, and 22 kilometers of tunnels. The absolute wildest part of that is an 18.3-kilometer tunnel cutting right through the solid earth at Lonavala. Plus, the whole system uses a broad-gauge ballastless track. Basically, they're ditching traditional gravel for solid concrete beds to keep things incredibly smooth and safe when you're moving that fast.
And here is the immediate massive payoff. All of that complex engineering, the viaducts, the huge tunnels, it translates to slicing the travel time between Pune and Mumbai down to just 40 minutes. 40 minutes! You're effectively turning two distinct metropolitan giants into a single, cohesive economic zone. And Mumbai to Ahmedabad? That drops to just 1 hour and 52 minutes. It's a total game changer.
And this kind of speed isn't just a vanity metric either. Passenger traffic on this corridor is projected to absolutely explode. By 2041, they're expecting it to hit over 104 million passengers a year, up from an initial estimate of 26.6 million. That level of demographic pressure is exactly why just upgrading the old saturated lines isn't going to cut it. An entirely new, high-capacity corridor is literally the only mathematical solution.
All right, moving to Section 3, the price of speed.
Because with the blueprints drawn up and the traffic essentially guaranteed, we got to look at the bottom line. How much does the future actually cost? Well, if we break it down, we're looking at a colossal 85,556 crore rupee total investment for the full Pune-Mumbai-Ahmedabad line. Notice how the basic construction eats up the lion's share at almost 60,000 crores. And you can't forget the trains themselves. You've got to factor in over 8,000 crores just to buy the initial high-speed rolling stock. So yeah, it is a staggering financial commitment.
But you know, building the thing is really only half the battle. Operating a system like this requires heavy annual maintenance. The study estimates over 250 crores a year just to maintain the infrastructure for the full corridor. which is exactly why they proposed a very specific, optimized fare strategy. 7 rupees per kilometer for 75% of the traffic and a slightly lower tier for the rest. They have to carefully thread the needle here, keeping the service affordable for the public while making sure the project actually stays financially viable for the investors.
Let's move on to our final section, Part 4, the Master Builders.
So how does this actually get executed in the real world? Because let's be real, you can't just hand an 85,000 crore, state-of-the-art infrastructure project to an organization that's used to running a 100-year-old legacy railway. You need a specialist, and that is why the government created a specialized engine for this exact task back in 2012, the High-Speed Rail Corporation of India, or HSRC. It was formed as a dedicated subsidiary of Rail Vikas Nigam Limited. It's a special purpose vehicle, meaning it's an independent entity created for one specific goal: to develop and implement high-speed rail projects in India.
You can basically think of the HSRC as a complete end-to-end pipeline. They're not just out there pouring concrete. They handle the whole shebang. They start right at step 1, doing all those dense techno-economic feasibility and bankability studies. Then they freeze the technical parameters, locking in things like signaling systems and track gauges. Step 3 is absolutely crucial, developing the public-private partnership models to actually finance the whole thing. And finally, step 4 is executing the construction and ultimately overseeing operations.
But here's the really smart part. The HSRC isn't doing this in a vacuum. Because high-speed rail is completely new territory for Indian engineers, they're heavily tapping into global expertise. They've formed active consortiums with some of the best in the world. You've got the Japanese agency JICA leading the charge on the Mumbai-Ahmedabad route. Francis Sistra took on the Delhi-Chandigarh-Amritsar study. And Chinese firms like Siyuan have been involved in the Delhi-Chennai planning. By partnering with nations that have already conquered high-speed rail, India is seriously fast-tracking its own learning curve.
So, we've seen the massive national vision of the Diamond Quadrilateral, crunched the hard regional engineering data, looked at the staggering financial realities, and explored the institutional framework designed to actually build it all. The preparation is definitely there, which leaves us with one final monumental question to think about. As the groundwork finally transitions from paper to concrete, will this ambitious gamble successfully redefine the future of Indian transportation? Or will the sheer scale of the challenge derail the dream before it even leaves the station? That is exactly what we'll be watching closely. Thanks so much for joining.